Hello, my student. In this video, we are going to learn about the set of real numbers. Let's begin with the Venn diagram. So the set of real numbers is the set of numbers that have natural numbers, which is the number that begin, the smallest number will be 1, and it will be increased by 1, so 2, 3, etc. And then the set of natural numbers is a subset of the set of whole number, because the set of whole number is bigger than the set of natural number by one number, which is 0. Okay, so it has 0, and then it include 1, 2, 3, so far and so on. And then the set of whole numbers is also a subset of the set of integers. So the set of integers include negative numbers such as -3, -2, -1, and then 0, 1, 2, 3, so far so on. And then the set of integers is a subset of rational numbers. So what are rational numbers? They are fractions such as 1/5, or decimal such as 0.25. So you can see that this decimal number 0.25 is also the same as 1/4. Okay, and then integer, you also can write each one of the elements or number in the integers as a fraction. So if I have -3, -3 is the same as, I write them as fraction, would be -3/1. Okay. So far we can see that natural numbers is the subset of whole numbers. Whole numbers is a subset of integers. So when I say subset, it means all the number in the, for example, all the number in the natural numbers belong to the set of whole numbers, and then all the number in the set of whole numbers belong to the set of integer, and the set of integer is a subset of rational numbers. So we use this notation for subset. Okay, so I'm going to say if I can say that I'm going to use N for natural number, W for whole numbers, Z for integer, and Q for rational number. So therefore I can translate it as natural number is a subset of whole number. Whole number is a subset of integers. Integer is a subset of rational numbers. So far you can see that the rational numbers is bigger than the set of integers, and it's also bigger than the set of whole number, and it's also bigger than the set of natural numbers. Now let's move on to irrational numbers. Irrational numbers are numbers that you cannot write in fraction. For example, pi. Okay. We all know pi is 3.1415 and so on. So even now we still do not know the end of pi. Okay. Or e. So we all know e is 2.17 something, and still we do not know. Or we can say square root of 2, say 1.14, and then so on. So all of these numbers, the decimal is repeated. Okay. So therefore, what is the set of real numbers? The set of real numbers including all of these numbers. So the set of real numbers have natural numbers, whole numbers, integer numbers, rational numbers, and irrational numbers. So far you can see that the Venn diagram tells you that the set of real numbers is the biggest set of number compared with the natural number, whole number, integer, rational, and irrational. So now let's go detail for the definition of each one of them. So let's start with natural numbers and whole numbers. Now on the left hand side, this column for you to write your own questions. So if you have any question, you need to write it right here. So when I grade your homework, I'm looking for at least one question. So here we are. Natural numbers, or we call counting numbers, are numbers in the set of, you start from 1 and they increase by 1, just like in the Venn diagram we just draw. And then we use the capital letter N. Just like when I assign your seat, I use the capital letter N to assign your seat, so just let you know that. And next one, whole numbers. Whole numbers are numbers that belong to the set of natural number, except it have one more number, which is 0. So that's why we can say that natural numbers is a subset of whole number, because every single number inside the set of natural number belong to the set of whole number. And also the set of whole number in this case will be, it have one number more than the set of natural number, which is 0. So we use this notation, and it's a subset of W. Natural number is a subset of whole number. So please write it down. Now we move on to integer. So here we are. Integers are the numbers in the set that you can see right here that integer have negative numbers and it have the whole numbers in that. So basically whole number is a subset of integer, and we use the capital letter Z. So that's why when we assign your seats, we assign using the set of numbers. So we start N for natural number, W for whole numbers, and Z for integers. Okay, next one now. The set of irrational numbers, we use the letter Q. So right here, I just go ahead and use the set notation. So we use the brackets. It's the set of all the number x. This part means such that x is a fraction p over q, where p and q are integers. So it means p and q belong to the set of integers. And q cannot be 0. So we cannot have 0 in our denominator. So make sure when you have a fraction, 0 cannot be in your denominator or at the bottom of your fraction. So far you can see that it's like we just did it on the first slide. We can see that natural number is a subset of whole number, because whole number is bigger than the set of natural number by one number, which is 0. Whole number is a subset of integer, because integer include negative and whole number doesn't have negative number. Integer is a subset of rational number, because rational number also include fraction that integer doesn't have. They such as 0.25 or 1/4. So please write it down to your note and make sure you include at least one question. Okay, so here this will be more example of rational numbers such as 3 over 5, negative 4 over 9, 0 over 8. Now you can see right here, it's okay to have 0 on the top of your fraction or on the numerator. So the top of we call the numerator. But it's not okay to have 0 at the bottom of your fraction or denominator. So just keep in mind. And we also remind you that rational number can also be represented as decimal. So you can see right here 4 over 8, we can write them as 4 over 5, we can write them as 0.8. Negative 27 over 4, we can write at negative 6.75. Now pay attention that the decimal, which is the number behind the decimal point, they are terminate. It means they stop. However, sometimes the decimal will be repeat. In this case, will be 2 over 3 will be the same thing as 0.66666. You don't want to just write the number 6 many times. So in this case, you need to write a bar. This is called the repeat bar on top of number 6. Okay, lastly will be irrational number. Irrational numbers is a decimal that neither terminate or repeat. So it means that the number behind the decimal point cannot terminate or it cannot repeat. So I'm going to give you these two examples. For example, pi 3.141592653559, and it will continue, but the decimal does not repeat. The same thing with square root of 2 will be 1.414213562, and again the decimal doesn't repeat. So I also have a note for you that if a number belongs to rational, then it cannot be irrational, and vice versa. It means that if you already classify that number belong to a group or belong to the set of rational, then you cannot say the same number belong to the set of irrational. Okay, so this will be the conclusion for this video. So let's write down the summary. So at the end of each video, you want to write down what you learned. Okay, so let's go ahead and write down the summary right now. So I'm going to go ahead and draw a line. So what I'm using the template right here. This is Cornell template. So I hope that from now on, when I grade your homework, you are going to write your notes like mine. So in this case, we say that in this video we learned that natural number whole numbers integers rational number and irrational number are subsets of real numbers. Thank you so much for watching this video. Goodbye.